I shall be discussing the concept of linear space. Linear spaces are defined over a mathematical term called field. You can't talk about linear space without involving the mathematical term called field. But then, what is a field? To understand linear space explicitly, you ought to understand what a field is all about. Now, what is a field? What is field? Now, a field is a set of numbers. A set of numbers. A field is a set of numbers. Let's call the set F, where the four basic operations we have addition, subtraction, multiplication, and division operations satisfies the following properties for every pair of elements in F. Now we are to satisfy the following property. The first property is for every pair. This is called pair. This is called pair. Where this first element is an element of this set F, and the second element is also an element of this set F. Now, a set F is called a field if the four operation, additive operation, subtractive operation, multiplicative operation, and divisive operation satisfies the following properties with respect to every pair of elements in F. Now, what are the first properties they satisfy? This is the four properties they satisfy. One, whenever this operation comes in between two elements, I'm talking about this pair where A belongs to F and B belongs to F as well. Now, this set becomes a field if whenever this particular operation comes in between A and B, its result becomes an element of F. The second one, whenever this operation comes in between any two elements of F, it's also an element of F. The third one, whenever this operation, multiplicative operation, comes in between two elements of F, it becomes, the result is also an element in F. Now, this divisive operation, whenever it comes in between any pair of elements in F, the result is an element in F. But note that division by 0 is not defined. That means B will divide A, or the divisor of A is B if B cannot be equal to 0. Hence, a set is called a field if for all four arithmetic operations these properties are satisfied. Now, using these properties, there are some certain properties that elements in F would satisfy using these four properties. Let's talk about those properties now. Remember that F is the set we're talking about, is a set of numbers. Now let's check other properties that elements in F will satisfy. Now when it comes to addition, additive operation, now between two elements in F, you see that addition is, this additive operation is an operation that doesn't depend on order. The result it gives whenever it comes in between A and B is also the result it will give whenever it comes in between B and A. So we say that additive operation in the elements of F is commutative. Hence, elements in F satisfies commutativity. And whenever it comes also between three elements, let's say the element of F, let's say whenever it comes in between A and B, addition does not, or it's not a function of order. Hence, it is natural that if it comes in between these two elements and this C element is also of this form. So addition naturally is commutative and what? Associative. Hence, element in F satisfies associativity. Okay, now you see using this operation, subtractive operation. Now we know that A, this is a pair. If A is an element of F, and if A also is an element of F, then since F is a field and these four operations satisfy these particular listed properties here, then if A and A belongs to F, now this implies that whenever this subtractive operation comes in between these two elements of F, it becomes an element in F. But now A minus A is equal to 0. This implies that 0 is an element of F. And what is 0 called? 0 is called the identity element with respect to additive operation. Now we are still on the concept of subtraction order. Now this is subtraction again. You see that we've derived that 0 is an element of F. So take a look at this particular pair now. This is a pair. You see this is a pair. The first element is an element of F, of which we derive from this that is an element of F, and we know that A also is an element of F. Now, since F is a field, whenever subtraction comes in between two elements of F, it belongs to an element in F. Now, this implies that if this sign comes in between 0 and A, it will be an element of F using this second property. Now, 0 minus A is equal to minus A. So this implies that minus A is an element of F. Now, what is minus A? Minus A is called the inverse. We say is the inverse of A with respect to additive operation. Now, you see we've gotten four properties that elements in F will satisfy. First, they satisfy commutativity. We talked about commutativity elements in F satisfy commutativity, and it satisfies also associativity, and also we obtain the 0, which is the identity element with respect to additive operation, belongs to F. Now F contains an identity element which is 0. At the same time, for all a elements of f, we have minus a to be an element of f. Now minus a is called the inverse of a with respect to additive operation. Now looking into these four properties state that f is called a group with respect to the operation plus. So we have this pair. We say that this pair is a group. Okay, and also you see that whenever this additive operation comes in between arbitrary pair of elements in F, it belongs to F. So we say that this plus is closed under, or the set F is closed for the additive operation. Okay, now let's move on to the multiplicative operation. We have multiplicative operation, and don't forget f is a set of numbers. Now you see the pair of elements for all a and b that belongs to f. Since this is a set of numbers, a is a number, b is also a number, but they belongs to f. Now whenever the multiplicative identity comes in between two numbers, what do you observe? Multiplying numbers, or the product between numbers, is commutative naturally. So since a and b belongs to f and a is a number, since f is a set of numbers, since a and b are numbers, hence their product becomes commutative. And also if there exist three elements, now let's say a and c is still the same if it is multiplied this other way around. So we talked about commutativity with respect to additive multiplicative operation, and we talked about associativity with respect to multiplicative operation. Okay, now let's come to this divisive operation. Now this divisive operation here, you see the when a is an element of f and a also is an element of f, you talk about from the given property we have from initial. You see the whenever divisive operation comes in between these two elements, it becomes an element of f, since f is a field. Now we have this is an element of f. Now a divided into a gives us a over a, which is going to give us what? 1. Now since a divided a is an element of f, so we say that f contains 1. And what is 1? 1 is called the multiplicative identity, or 1 is called identity element with respect to multiplicative operation. We say it's called the identity element with respect to multiplicative operation. Okay, now since 1 belongs to f, let's look into this once more. Since 1 belongs to f and a is an element of f, this implies that since f is a field, this property is among. So we have 1 dividing, or a dividing into 1 will become an element of F, since F is a field from the given four properties. But we know that 1 dividing A is the same as when we say 1 over A, which is an element of F. Now, but what is 1 over A called? 1 over A is called the inverse of A. We call it the multiplicative inverse. We call it the multiplicative inverse of A. Why is it called the multiplicative inverse of A? It is called the multiplicative inverse of A since 1 over A multiplying A will give us the identity element 1. When A cancel out A, we have 1. And 1 is called the multiplicative identity. Okay, now what is the next property that elements in F will satisfy? Now if we have from factorization, if we have A multiplying C plus A multiplying B, now I can factorize this to be A C plus B. This is one of the properties that elements of F would satisfy. At the same time, if I have C and A plus B and A, you see here A is common. It's still the same way if I put on the bracket and have my A outside. So using those properties, these are the 9 properties that elements of F will satisfy. Thanks for watching. Stay tuned.